I'll be explaining some important topics in physics, like vectors and scalar quantities, and distance and displacement, along with a few examples in real life. Displacement, simplified, is basically how far an object has moved from its original location. It's how much an object's position has changed, but measured from one point to another. It might seem the same to distance at first glance, but distance tells you how far you've traveled in total, while displacement just tells you how far away you are from your starting point. Also, displacement is a vector quantity, which means it has a magnitude, an amount, and also a direction. On the other hand, distance is a scalar quantity, which means it just has magnitude but no direction. Here's a scene. The starting point is a flower pot, the white sign, at 0 meters. At the far right end is a piece of wood at 8 meters. Halfway across is a big tree at the 4-meter mark. First walk. Laurel's on a walk with her dog Caius. She walks past the flower pot, past the tree, and ends up near the chunk of wood. What was the distance she traveled? How far did she walk? In this case, the distance she walked was 8 meters. Her displacement from the starting point, the flower pot, is 8 meters right. Distance is the length of the path she traveled, while displacement is the distance and direction between the starting point and the end point. Remember, displacement is a vector quantity, so the direction, not just the magnitude, needs to be included. In this case, it's right. Second walk. Let's do this again. Say Laurel walks to the chunk of wood like before, but then travels back halfway. Now what's the distance she traveled? She would have traveled 12 meters. She walked all the way to the piece of wood, 8 meters, and then halfway back to the tree, 4 more meters. But what about the displacement? Her displacement, the distance and direction between the starting point and the end point, is only 4 meters. She's been displaced by 4 meters. Third walk. Laurel walks all the way to the piece of wood, 8 meters, and then all the way back again to her starting position, another 8 meters, making for a total distance of 16 meters. This means the distance she traveled is 16 meters. Yet, she's right back at the beginning, so by the end she hasn't been displaced at all. The distance and the direction from the starting point to the end point is 0, so her displacement is 0 meters. Hopefully this has given you a bit of a better idea between displacement and distance. Seeing displacement in real life is helpful, but how do you actually find the displacement of a person or object if given a word problem? Here's an example. A girl walks from the top of her driveway to her house, traveling 23 meters east from her driveway. What is her displacement? Even though you could probably figure out the displacement in your head, there's actually a special formula you can use. Displacement equals final position minus the initial position. Using this formula, let's figure out her displacement. Her final position is the position she ended at, which was 23 meters east of the driveway, at her house. So now we know displacement equals 23 meters minus the initial position. What was her initial position? Her initial position was the top of the driveway, where she started, which had a position of 0 meters, the starting point. Displacement equals 23 meters minus 0 meters. 23 meters minus 0 meters is 23 meters. This means her displacement from the top of the driveway to her house was 23 meters east. Although the displacement formula wasn't that helpful in this case, as you probably could have done this question without it, here's a harder situation where it is often useful to use. Like, wonder if the distance a person or object traveled was positive and negative. Think of a Cartesian plane. The top line is positive, the bottom line negative, the left line negative, and the right line positive. This is like how directions with vectors work. For example, north and east are both positive, while south and west are both negative. Up is positive, while down is negative. Left is negative, while right is positive. When you were putting, for example, 10 meters east or 5 meters down into an equation, you would need to use either a negative or a positive. 10 meters east would become plus 10 meters. 5 meters down would become negative 5 meters. Knowing this, let's go through a harder question. A girl rides her bicycle from 6 meters right of a chair to 4 meters left of it. What is her displacement? To find displacement, as you already know, you need to subtract the initial position, the position the person or object started, from the final position, the last position the object was. The origin is the chair, which has a position of 0. Anything left of the chair will have a negative position, and anything right will have a positive position. Her initial position was 6 meters right of the chair, plus 6, and her final position was 4 meters left of it, which will make a negative, minus 4. Let's input what we know into the equation. Displacement equals final position minus initial position, so displacement equals negative 4 meters minus positive 6 meters, which makes a displacement of negative 10 meters. Since the negative sign means left, her displacement was 10 meters left.
Oh. That doesn't count.